Hello, this is Module 4, Investigation 7, Investment Activity, and focus on the formula and motivating me. Earlier investigation, I introduced the compound interest formula, but this time I'm going to introduce the compound interest formula continuously. All right, let's try the number 1. So 1,000 is invested into the account with the annual percent rate, APR of 8%. Given the compounding period, determine the account value at the end of the fifth year. Also determine the annual percent yield APY for the given compounding period. Round to the least 3 decimal place. All right, so compounding the yearly means, okay, so you getting an interest every year. And then quarterly means you getting a 4 times. Monthly means you getting 12 times because there's 12 month a year. Daily means you're getting it 365. And for the hourly means, you need to multiply 365 times by 24. And then I have 8,760. And then for the minutely, you need to multiply 60 to the 8,760. And then you're getting 52,000. No, 525,600. Okay, so that's the end. So n is getting bigger. So the meaning of the n getting bigger, you get the interest more often. Okay, so APY first. Okay, so let's see. So for the compounded interest formula is the for the growth rate is 1 plus r over n to the nth power. So that's what I'm gonna use. So 1 plus r is the that is 8%, which is 0.08, and is a 1 for the annually to the power 1, right? And then you are getting the 1.08. And then to find out the percentage, okay, so you guys are going to be 1.08, subtract the 100, sorry, we have to make the percentage, okay? So 1.8 is a percentage, 108%, subtract 100, and then it becomes 8%. Okay, for the n equal to 4, which is quarterly, now 1 plus 0.08 over 4 to the fourth power, which come out as 1.824, 08, 1.0823. So if you change the percent, it's going to be 108.243% minus 100% will be the 8.243. So because of the we changed the quarterly from the yearly, and then percent is getting higher. Now monthly, I got 1 plus 0.08 over now 12 to the 12th power, and then it becomes 1.08 and 300. And then change the percent, so 108.300% minus 100, it becomes 8.3%. This is a percent, okay? And then for the compound daily, it becomes 1 plus 0.08 over, daily means 365 to the power 365. And then that means 1.08 and 328. Change the percent, 108.328, subtract the 100, and then we get the 8.328%. And then for the hourly, 1 plus 0.08 over 8,760 to the 8,760 power, and that becomes 1.08 and 329, which is 108.329, and subtract the 100, we'll get the 8.329. And then for the every minute, 1 plus 0.08 over 525,600 to the 525,600, and which becomes 1.08329. And then 108.329 subtract 100 becomes 8.329. Okay, so next that's the percentage, okay? And then next the one we want to subtract to find that we want to find the difference between the two APY value in a row, okay? So we have a 8%, and then subtract from the 8.23% is, so in order to do this is, let me use a red, okay? So 8.243% subtract the 8, I got 0.243% increases, okay? So same idea too. Now I'm subtracting from the 8.3 to the 8.243, okay? And then I'm getting 0.057%. The next one, I am subtracting from the 8.328 to the 8.3, and then I got 0.028%. And then next one, I'm subtracting from 8.329 to 8.328. I'm getting a 0.001%. For the next one, I'm subtracting from 8.329% to the 8.329%. It becomes 0.000%, right? Okay. Now we can find the investment after the 5 years too. So investment for the 5 years, now we have to use the years as a 5. So what I use is I'm gonna do as we're looking for the amount, right? So P times of 1 plus R over N to the R to the Tth power, okay? Which is, we already have this as here, as a 8%, 0.18, and then 0.08243 like that, okay? So that's what I'm going to use. So on here, so investment of the 1,000 of the 1.08 to the 5th power, because 5 years, becomes $1,469.33. Next one, 1,000, 1.08243 for 5th year. I got $1,485.93. Next one is 1,000. Now the percentage 1.08 300 to the 5th power will becomes $1,489.85. For the next one is a 1,000, rate is 1.08328 to the 5th power. It becomes $1,491.78. As a 1,000, now 1.08329 to the 5th power becomes 1491.84. And then there's no percentage, it's the same percent, right? So 1.08329 to the 5th power because 1491.84. And then I'm looking for the difference of the investment, okay? So on here, I'm subtracting the 1485.93, which is from here, and then subtract this one. Subtracting the 1469.33, which is I got as 1660. I'm subtracting again. Now from the 1489.85 to the 1485.93, I have a 3.92. And subtracting the 1491.78, subtracting 1489.85, I got 1.93. 1491.84, subtracting 1491.78, I got 0.06. And then I got 1491.84, subtracting 1491.84, it's going to be the 0. Okay, so what you can see is, okay, so when you actually get up to the daily, right, sorry about that. So up to the daily, right, daily, and then it's been increases up to here, right? Which is increase amount is high is actually this one though, right? But that's still increasing it. But after that is severely not that much increases, right? So as you notice here, right? So there was 1660. That's the big difference between the yearly and quarterly, and then the monthly and quarterly about 3.92, and that, right? After that is only a few cents, right? So once the interest periods are really small, we might want to stop doing it, okay? So that's why we're going to do as a compound interest continuously. So let's think about number 3. What do you anticipate the APY will be if the APY is 8% and the investment is compounded every second? So every second means from the 525,600 as a minute. Now you just need to multiply 60 again, and then that will becomes the 31,536,000. That's the second. That's the seconds, okay? All right, that times. That makes it every seconds, okay? All right, so if you do as so if you want to think about the APY, which is from 1 plus 0.08, it's the same 8%, but you have 31,536,000 to the 31,536,000, which is you're gonna get as 1.08326. So that even smaller, right? That is even smaller than this, right? So yeah, so why you wanna go to the second? Then they're also asking for what about 100th of the second? So 100th of the second means that we have a 31,536,000, but you multiply by 100, which becomes 33,153,000, a million 600,000. Okay, so yeah, but we don't really care. Okay, so after the daily, the amount of the interest is not that big deal. Okay, so B, what do you predict in the large annual factor possibly given an API of the 8%? Interpret the meaning of this value in the context in this situation. So it appears that the largest API is about 8.329%, and then after we get into the seconds, and then it getting even smaller, right? So what we can do is impact of the increasing the frequency of the compounding becomes negligible. So we want to say that the impact of increasing the frequency of compounding becomes very, very, very small. So we can ignore that, right? Beyond certain point. So which means I want to say is beyond the daily, okay? So we're just not going to try that, okay? Alrighty, let's go to the number 6. So now we have a same investment, $1,000 was made in the 4 different banks at the given APR. Complete the table by defining the largest annual growth factor for each APR, and this value should be a decimal. Since this decimal is a rounded value and therefore not exact, complete the second row by writing an expression that determines the exact value of the largest annual growth factor. Finally, write the formula can be used to find the maximum value of the investment after T years, the value of the investment assuming the largest annual growth factor. So the largest growth factor is here. So what I can do is I want to assume that n is 10,000, which is big enough, right? This is actually the more than the hourly, okay? So what I do is, okay, so 1 plus 0.05 as a 5% over 10,000 to the 10,000 power. And then it will becomes 1.05, 1271. So next one is now changed to 6%. So 1.06 over 10,000 to the 10,000 power. It becomes 1.06, 1836. For the 7%, 1 plus 0.07 over 10,000 to the 10,000, which becomes a 1.072508. And then 1 plus 8%, 0.08 for 10,000, 10,000, becomes 1.08 and 3287. Okay. Well, but that's the number that I can introduce here, which is I already talked about in class now, okay? So in here, if I have a 1 plus r over n to the nth power, right? Well, I want to consider it as 1 plus r is a 100% as n over n. And then what I'm going to do is I'm going to change the n goes really, really big. So if you do that, so n going to be 10,000, n could be the 100,000, millions, right? So at that time, it becomes the very close to the number e. So e is number that is about, you can use a calculator to figure it out. So as a e that I want to introduce here. So you got the e as about 2.7182 so on. Okay. All right. So instead of the using the bigger n, okay, we can use the e. So if you use the e to the 0.05, and then you'll get close to 1.051271. E to the 0.06, similar to the 1.061836. E to the 0.07, similar to 1.072508. And e to the 0.08 is about 1.083287. Okay, so now we can make the formula, which is going to be the P. So formula will be here as amount will be the P e to the RT. So our P is 1000, and then e to the R is a 0.05 as how many? Just the years you put it as a t. So you got 1000 e to the 0.06t, 60, and then 1000 e to the 0.07t, 1000 times e to the 0.08t. Okay, so let's try number 8 to using those forms. Okay, so number 8, 1500 is invested. So we call this formula as a compounded continuously formula. Okay, 1500 is invested into the account with the advertised APR was 7% compounded continuously. That's why we have to use P times e to the RT. So determine the value of the investment after 6 years. Okay, so A of T, so T is a 6. So look at the amount is principal as a 1500, e to the R is a 7% for 6 years. And then I have $2,282.94. Now determine the amount of the time required for the value of the investment doubles. So which means double means from the 1500 is a 3000. So in order to get 3000 from 1500, e to the 7% for the t. We're looking for t. So how many years we're gonna get? So what we need is I want to make a table for t to plug it into 1500 e to the 0.07t. But already A for 6 years is already 2,282, right? So if you get that as if you're gonna find that as 7 years and 8 years and 9 years and 10 years, okay? So you can think about that. So as a 7 years, you get the 1500 e to the powers of 0.07 times by 7. Then I got about $2,448.47. So still not the 3,000 yet, so it should be more than 7 years, right? And then for 9 years, I have to use 1,500, and then the base e to the 0.07 times 8 years, okay? And then it becomes $2,626.01. For the 9 years, 1,500, and then e to the 0.07 times 9 years. And then I got 2,816.42 cents. Still not the 3,000 years. So it's going to take them more than 9 years, right? But very closer. Okay, so let's use a 10. 1500 e to the 0.07 times 10, which is, oh, so now more than the less than 10 years, right? So I want to say it's going to be the between. So it'll be the years is a between 9 years and 10 years. And then you can just go for the more, like a 9.2, 9.3, 9.4, up to 9.9. Then about t equal to 9.9 years, you get actually very close to 3,000, which is going to be double amount of money. All right, determine the value of the amount after 6 years. Had the investment been compounded quarterly, so we are using the periodically compound interest, right? So the amount will be the principal of 1 plus r over n to the t power, right? So principal was the 1500, and then 1 plus r is 7% for the quarterly for the 6 years, right? So it become $2274.66. So when you are comparing this amount to this amount, actually the continuously compound just give you the more amount than the quarterly. All right. Okay. I think that's all for this investigation. Thank you for listening.